So I'm really delighted actually to be here today to just give you a very, very short overview about a couple of points that in fact have already been majorly discussed with the speakers just before, but perhaps some points could also be reiterated here just for completion's sake. So the first thing I wanted to mention are, in fact, digital pathology is a very big IT project. It's very easy to get distracted by all of the nice to haves and to not focus maybe entirely on the must haves. And those must haves are, of course, a pathologist-centric approach. So the first thing that many of the speakers before have discussed is, of course, the inclusion of AI algorithms into IMSs, which are really there to hopefully alleviate the work of pathologists. However, there can be a distraction when it comes to new tools. It's a very exciting field, and being able to include deep learning algorithms into sort of daily routine of pathologists is something that is very, very exciting. However, it's very easy also to get off the course with what is exactly needed by our pathologists in order to really alleviate work and reduce time. So on the one hand, there is, of course, algorithms that might detect cancer. However, there's also the much more, let's say, difficult task of counting features, but those features have to be basically counted or quantified in correspondence to a certain guideline. Pathologists are working based on guidelines, and they have to produce results that fit into those guidelines. And if it's outside of those guidelines, for instance, instead of looking at a particular region of interest for Key 67, but looking at the whole slide, what do you do with that information that comes in from the whole slide? So this is just to underline the point that sometimes the communication between computer scientists or people who are developing those algorithms and pathologists who are really using those algorithms needs always to be strengthened. And this is not always such an easy point, because those two different kinds of people might also be working at different institutions, different kinds of, they have different kinds of industrial partnerships. So that's maybe one point to really just highlight the communication and the working together between computer scientists, the people designing algorithms, and of course, the people who are really at the source using them in a daily way. The second point is about integration of different components. So let's assume we do have these AI algorithms that are being produced. Now it's time to really include those in a seamless workflow. Digital pathology is more than just a slide scanner. It was mentioned earlier. It starts at the time even that the message is arriving to the Pathology Institute that there is a specimen that is there. So that whole process, which can be a paperless transmission, which can affect every single step in the lab, from improper, let's say, barcoding, to cutting sections that are too thick, to making sure that the dyes or the colors in the lab are staying the same over time, to, I think I mentioned, thick sections, which can all affect, for instance, how the scanner is going to take these focus points. All of those kinds of pre-analytical variables. This is even way before the slide or the scan even shows up in the IMS of the pathologist. That's really the seamless workflow that we're talking about from beginning to end. So it's easy to forget that point. And of course, this is made for the pathologist to be able to have as few possible clicks as possible in order to reach their goal. So we had this as a big experience here with us. We are, of course, using different components of our digital pathology system. It does not come from one vendor or even two vendors. It comes from multiple vendors. And we want that all of these points be integrated to the point where our pathologist doesn't need to click to open another, let's say, another product that is 1-2 clicks too many. And then they will not be enthusiasts of digital pathology. This brings me to the third point, which is really this openness of systems. We want to be able to play with different components of the system. We don't necessarily want to be locked in. We want to use what comes out of diagnostics for research, and we want to use what we've done for research to try to put that into diagnostics. It's a vicious circle, at least for those people who are interested in doing research at their institutes. It's something to never forget. How do you utilize the power of the research side and diagnostic side and put these two things together? This is not so easy, and actually took a few years of experience from our side to figure out how to optimize this process and not get tricked into buying something that maybe doesn't even allow us to export our images. And the final thing is the structured reporting, which is something that someone else also mentioned, I think Professor Yang at the beginning, about finding our images once they are produced. So it seems like something so basic, but many, if not a large majority of pathology institutes are still not working with structured reporting, including ours. So how do we even find the cases that fit certain criteria in order for us to continue our education, or even to bring out those images for development of AI algorithms with? It's impossible for us even to find cases in our LIS. This is something that is so basic, but is only going to be accentuated in this world now of digital pathology. So structured reporting is something that I would like to suggest to everybody to very seriously contemplate. And so that's all I would like to say at this point. Thank you very much for your attention. And of course, I'm here in case you have questions.